This is example 14.2 from Discovering Design with Chemistry. The problem asks, what is the change in H of the decomposition of hydrogen peroxide at 25 degrees Celsius? And they've given us the formula for that below. Is it exothermic or endothermic? So to find the change in H, we're going to use this new formula that we've just learned, where we take the change in H of formation, the enthalpies of formation for each of these different things, and then we multiply them by the little letter in front of each. Tells us that we multiply it by the number of moles that involves, and then we just put it in the thing. So let's start by finding the change in HF, and this degree symbol just means this is the formation at 25 degrees Celsius, and that's why they included that in the problem, but we don't actually need to use the number of the problem. That number just tells us we're allowed to use the chart that we've been given in the book. In my book, it's page 424. So for H2O2 in aqueous form, it is negative 191.2, and that is kilojoules per mole. They're all kilojoules per mole, but I need to write that. All right, so H2O in liquid form is negative 28, is liquid form, right? Yeah, negative 285.8. Negative 285.8, again, kilojoules per mole. And then our last one is oxygen gas. Any element in its natural phase, which oxygen, oh, sorry, you know what, just kidding, it's not oxygen gas because I forgot to put a G there. I was copying from a previous problem. The problem in the book says gas, and I should have changed that to a G, but I didn't. Now it is fixed. All right, so the oxygen is in gas phase here, which is its natural phase at 25 degrees Celsius. And so that one, it's just 0. So we could actually just leave that out of the problem. So in our formula here, where we have change in H, we have all of our C's and D's, which come from here, all of our products first being added together, and then we subtract our reactants. All right, so our change in H for this, we're going to take products minus reactants. All right, so these are our products. We're going to start with these. So we have 2 moles times negative 285.8, that's kilojoules per mole. And then we could add that we have 1 mole of oxygen gas at 0 kilojoules per mole. You probably easily recognize that 0 times anything is going to be 0, so we don't even have to include this one. This part can just kind of be left out. And then we're going to subtract the reactants. So we have 2 moles of, let's put the word moles, of our hydrogen peroxide, and that's negative 191.2 joules per mole. And then we just put this into our calculator. All right, so 2 times negative 285.8. See how my calculator does 0 minus, that's just how it shows up. And then I'm not going to even put in plus 0 because I know that plus 0 is still the same. Minus 2 times negative 191.2. All right, in this case, we are just adding and subtracting. Remember, we can't have a piece of a mole. And so those numbers, those coefficients out front that came from the problem, like that little 2 moles that came from the 2 in front of H2O2, does not count. So all that matters are our numbers like 258.8. So that has 4. And then 191.2 has 4. So I'm sorry, why did I just say that? We're adding and subtracting, so we care about place value. So 285.8 goes to the 10th place, and 191.2 goes to the 10th place. The zeros don't count. That's just, we don't have to worry about the fact that 0 is in the 1's place. It could be 0.0000. So we're going to keep this one in the 10th place, which means our answer is just what we see on the calculator, negative 189.2. And because all of our moles canceled in the problem, the unit is kilojoules. All right, so that's the answer to the first one in this example. The question that it asks next is it exothermic or is it endothermic? Because change of H is negative, This one is going to be exothermic. All right, let's move it to the side for the next problem. And I just realized this kind of covers up, shows a little bit of my other problem. That's okay. We just won't use green in this problem. All right, so again, we're asking what is the change in H for this reaction. They tell us is at 25 degrees Celsius, which means we can use the little change in HF degree symbol. So we can use that chart of standard enthalpies of formation that's found on probably page 424 of your book. So since we know we're going to use this formula and we need all those change in H sub F, however you want to read that little thing, we're going to find them all. So let's start with carbon monoxide. So this one in gas form on our chart, that is negative 110.5. 110.5 kilojoules per mole. Next we have water, but it's in gas form this time. So we have to be careful not to use the H2O that we used last time because that was in liquid form. So in gas form it is negative 241.8 kilojoules per mole. All right, next we have CH4, and that's in gas form. That's negative 74.9 kilojoules per mole. And then last we have O2, and again it's in gas form, so this is just going to be 0. All right, so when we find our change in H, we start with our products and we subtract the things at the beginning. All right, so we're going to have, we have 2 moles. Let's do change in H equals. We have 2 moles of CH4, that's 74.9. And the reason we do these first is because we want them to be positive. Let me see. All right, we're not going to do the 0. I'm just going to put 0. So we know that we thought about the oxygen, but we know it's 0, so we're not going to deal with that. I'm just going to put a 0. And then we have 2 moles. Oh, I forgot my unit. Negative 1 point for me. Okay. 2 moles of CO, and that's negative 110.5 kilojoules per mole. Now I can finally move this over. We know our formula, so we don't need to see the rest of it. And then minus 4 moles of H2O, and that's negative 241.8 kilojoules per mole. All right, let's use blue. All right, so moles cancel here, leaving us with kilojoules everywhere. And all of our things are to the 10th place, so once we get our final answer, we're going to keep it at the 10th place. All right, so let's move the calculator a little bit so I can see what I'm doing. So 2 times negative 74.9 plus 0, I'm not going to include the 0, minus 2 times negative, that might blow up my, let me start over. That might blow up my calculator because I forgot to put parentheses there. 2 times, oh, of course, okay, let me just hit enter and then clear it. There we go. 2 times negative 74.9. I tried to download a scientific calculator to make these videos easier, but I just did not like any that I found. 2 times parentheses negative 110.5 minus 4 times parentheses negative 241.8. All right, there we go. And we're going to keep all of those because we need it to the 10th place. That is the 10th place. So 1038.4. 1038.4. That's in kilojoules, and that is our change in H for this formula. Now this time it's positive. So because change in H is positive, that means it's endothermic. All right. There are both problems. I'm not sure if that's helpful because it's probably too tiny on your screen.